Okay, we want to rotate on a coordinate plane. The reason that we might want to do that is because coordinate planes have scale. All these lines have equal length, equal unit measure. Say they were inches, or if we wanted to measure, we could do scale factors because of the unity in coordinate plane here. So if we want to rotate on a coordinate plane, it's really the same thing as if we rotate without a grid or axes. It's just that we have scale and we can do a lot more with numbers and behavior on a coordinate plane. So let's talk about how to rotate on a coordinate plane. Since we're talking rotations, you need to think about where we're rotating around, or the center of rotation. That's always going to be the origin when we talk about a coordinate plane. It doesn't have to be. We could rotate on any point, right? It's just that when we talk about rotating on a coordinate plane, we typically are going to rotate around the origin. Okay. If you're going to do this by hand, you're going to need to measure the angle that we want to rotate. So you're going to need a protractor. All right. So I'm going to show you how we can do that. All right. So let's say that we have a coordinate plane here. Some triangle. I'm calling it CBA. This triangle right here, and we want to rotate it, say, some degree. In this example, I want to rotate it 215 degrees, which, because a full revolution, right? If I take point C, for example, this one right here, and I rotate it around the origin, say 360 degrees, or a full rotation, right? It would just map back onto itself right here. And same for A and B and all the points that make up these segments, right? Every infinite point in this triangle would rotate exactly where it started if we went 360 degrees. So that just means that if we want to go to, say, 215 degrees, that's not a full revolution, right? That's just more than, and if we want to go counterclockwise, say this direction, right? 215 degrees, we can think about this. The axes are perpendicular to each other, and remember, perpendicular means 90 degrees. So if you think about rotating C 90 degrees counterclockwise, wouldn't C, which it's 2 units from the origin, right? Wouldn't C rotate then 2 units to the origin on a perpendicular line, right here? That's a 90-degree rotation over about the origin. So we're not quite to 215, so let's rotate another 90 degrees. So say C rotated 90 degrees to get to here. Let's rotate another 90 degrees, which C then would just be on the opposite side of the axis here on this straight line. Remember, lines have angle measure of 180 degrees. It's like a 90 degree and another 90 degree rotation. C would end up right here. That's 180 degrees. We're almost to 215. The difference between 215 and 180 is what? 35 degrees. So if we went 90, 90, and then another 35, C would end up somewhere over here, right? Same deal with A. We would just have to go, 90, 90, and another 35. Same with B. All right. I'm going to show you, well, let's just do this with GeoGebra now, and then I'll show you how we do this by hand with a compass, okay? So the origin here is going to be our center of rotation. So I'm going to put a point on the origin. All right. So now, whether we have the grid or not, I'm going to take off the grid and I'm going to take off the axes. This is just a blank plane, right? Two-dimensional space. And we could rotate this triangle 215 degrees. All that we have to do, and I'm going to just do one without the grid, and then I'll do the other two with the grid. I'm going to take C since we're talking about it. To rotate C, and by the way, since we're rotating this triangle, there's 3 key points that we want to talk about. The vertices, right? Let's just focus on each one of these, rotate each point, each vertex, and then we basically have the triangle, right? Because the segments are going to rotate the same as well. Okay? So all that we need to do is connect C to D, right, to show that visual distance or path from the center of rotation to the point I want to rotate. Now we want to rotate C 215 degrees counterclockwise, okay? So what I'm going to do is grab my rotate tool, rotate object tool. I'm going to click on what I want to rotate, say C. Oops. If something happens like that, like it just doesn't, it pops up and you weren't ready for it, I just always hit escape on my keyboard and then I just retry. I'll grab my rotate tool again. I'm going to click on C because I want to rotate that. Then I want to rotate around point D. We want to go counterclockwise, and let's put 215 degrees in here. I'm going to click OK. And notice C, remember, if we're talking that grid, C would have rotated 90, and another 90, which is 180, and another 35 degrees. So here's a rotation, C going around the origin. If I use the circle, since rotations have equidistant, we can kind of see 90, 90, and another 35, right? Or to finish off that angle, there's our 215 degree angle here, right? Okay. So whether we had the grid or not, there's our 215 degree rotation. Let's just do that to the other 2 points here. Okay, so now I'm going to take this distance, right? Maybe make that a different color just to stand out. I'll make it green. I'm going to rotate this 215 degrees. Okay, so now I'm going to take grab my rotate tool. I'm going to take this segment and I'm going to take what am I doing here? Rotate tool. I'm going to take go around the center, the origin here. Notice it's already set up, so I'm going to click OK. I can do the same thing with the segment here. I can click on my segment, and I can click on the origin. Segment, origin. Why is that not working? Segment. Sometimes this happens. There we go. So now I can rotate that segment to 215 degrees. So there's my 215 degree rotation, right? That would be the same thing as if I did this circle. We can just kind of see that path again. Just kind of want to just put everything together for us. Make that green too. And then the last one we got to do is the distance from B to the origin. We'll make that maybe blue. And then I'm going to rotate this then. I'll rotate B about the origin, 215 degrees counterclockwise, which it went way up here, right? And now I'm going to do the same thing with the segment, just to rotate that too, 215 degrees. There we go, that worked nicely. So now I can see my 3 key points here, right? My 3 points right here. Boom, boom, and boom. So now if I connect those, because really if I take this segment and I rotate it, that segment would just rotate right here to C prime, and then what GeoGebra is calling this A prime 1, right? That's the same segment here. Maybe we'll keep it blue maybe. And then if I rotate this segment AB, wouldn't that just rotate 215 degrees here to this A prime B prime? This segment right here, right? Keep the same length, congruent. And then BC would rotate to B prime C prime. So there's the triangle rotated about the origin, right? 215 degrees. Holy cow. Let's do another one of those, and let's use a compass here and a protractor, and let's do this by hand. Okay, so let's take this. We're going to rotate this point A. Let's start with this point A here, 35 degrees clockwise. So clocks go this direction, right? So A is going to rotate 35 degrees this way, all right? So if you imagine, say 90 degrees would be perpendicular, something like here. So we're not going quite this far. So 35 is about a third of 90, isn't it? Close to it. So then a third of that would be somewhere like here. So I would imagine A going somewhere like right around here, right, if you kind of think about that angle. All right, so let's actually do this here. I'm going to grab my pen, and I'm going to make a point, just like in GeoGebra, I'm going to make a point with my pen here. Here's the origin, kind of, right? Okay, there's my center of rotation. Let's go 35 degrees. So I want to visually see that distance here, so I'm going to use my segment tool. All right, now I want to rotate A 35 degrees, and that segment helps me as my starting side of an angle. So when I get my protractor out, when I get my protractor out here, okay, and I want to go this way. So since the vertex is my center of rotation, I got to put the crotch of my protractor. Okay, on there. I'm going to start on this segment here, right? That's my starting side. And now I'm going to just rotate 35 degrees. So if I can look at my protractor, 35 degrees is between 40 and 30. So I'm going to mark that with my pen. You do this with your pencil at 35 degrees right here. Right? There's 35 degrees, that line right there. Alright, so now I can move my protractor. And I know that if I go from the origin through this line here, so I'm going to grab my segment tool and draw that line, that's a 35 degree angle, right? Put that on my protractor back on there, and notice we get a 35 degree angle. Okay, so now remember when it rotates it has to be equidistant from the center of rotation, so I'm just going to use my compass and I'm just going to create a circle here. So I need to change my radius to be this distance, right? And now I can just make my circle till it intersects that line. That's really the point that I want. So A just rotated here, right? Here's A prime. Okay, now what if we had a triangle here? So there we just rotated A. Now if we had C and B, we would do the exact same thing, wouldn't we? We would grab our segment tool. If I'm going to rotate B, there's my segment. That's my starting side of an angle. I need that segment so that I can grab my compass and rotate this thing. It's starting center at the origin, right? And it's starting here at this side, so that's on my 0 line. I want to go 35 degrees again. So here's 35, say right here. Move my compass. Draw my new ray from the origin, right? Because that's our center of rotation. That's where the angle is made. And there's my 35 degree. And then just to get B in the right spot, I'm going to center my compass. Okay, at the origin, make my radius go out to B. And now I'm going to draw my circle where it intersects that line, is really all I care about. And now I've got B. Okay, so this is B prime. This is A prime here. So we just have one more. We have C. Okay, getting kind of a mess here. If you're using your pencil, I would recommend erasing some of the lines. Now that we got the points where we needed, all those circles and segments and things that we drew that we needed for the angle and for finding equidistant, you can get rid of them. We don't need them. So I'm going to get rid of them. So try to erase them or draw them light when you do this. So they're just guidelines here. So now if you erase a lot of what we did, it'll kind of clean up everything. Oops, I don't want the grid gone. Okay, so we have A prime, B prime, and then I'm just going to do this one more time. So I can see my segment, the origin to C, that's just on the x-axis, right? That's my segment. So now if I'm going to go counterclockwise, or excuse me, clockwise, I'm going to start on the x-axis here, right? That's my 0, my starting line. And now I'm going to open up 35 degrees. So I'm going to grab my pen here, and 35 degrees would be like right there. Move my compass or protractor and draw my second side of my angle. So my angle is this x-axis to here, right? And then find that equidistant. So I got to make my radius, the length out to C here. Okay, now I can just make a little arc here, really, just part of a circle. That's really the only point I need. So here is C prime. All right. So now I'm just going to make my triangle. Right? And there's this blue triangle rotated 35 degrees clockwise around the origin. Alright, good luck with that, guys. Your constructions, all it takes is making an angle, using segments to visualize your angles as a starting side, and then rotating the angle measure to get to your other side of your angle, and then just finding equal measure with your compass. Okay? So good luck with that.